A boat begins to travel from point A to point B across a river with a speed of 5 meters per second at an angle of 60 degrees with the horizontal. So this is the intended direction of travel. The velocity of the river is 3 meters per second to the right, and the width of the river, d, is 100 meters. What would be the velocity of the boat with respect to the ground? So we are given that the velocity vb with respect to r is of magnitude 5 and vr is of magnitude 3, and we have to compute the magnitude of the vector vb, which is the velocity of the boat with respect to the ground, so as seen by a stationary observer. The vector vb with respect to r can be resolved into its x and y components, that is 5 cos 60i and 5 sin 60j. Vr has only a horizontal component, which is 3i, so we obtain the vector vb as 5.5i plus 4.33j. The magnitude of vb is 7 meters per second, which means that as far as an observer on the ground is concerned, the boat moves along the line AC with a speed of 7 meters per second. Now let's find the time it takes to cross the river. If we take the y component of the velocity vb, it is 5 sin 60j, and there is no acceleration in the y direction. So the time taken is the distance 100 meters divided by the velocity 5 sin 60. So we obtain the time taken to cross the river as 23.09 seconds. We could have also done the same using the line AB. In this case, the distance would have been the length of AB, which is d over sine of 60, and the velocity along line AB is vb with respect to r, so we would end up with the same value for time. Also, if we knew this distance AC, then we could have also obtained the time as the distance AC over the magnitude of the velocity vb. Next, let's find out the angle AC makes with the x-axis. You can see that the boat travels along line AC, that is, along the vector vb. We have already established vb as 5.5i plus 4.33j, and therefore we obtain the angle alpha as the tan inverse of the y component over the x component, which is the tan inverse of 4.33 over 5.5, and that turns out to be 38.2 degrees. This is the angle the boat makes with the horizontal, labeled as alpha. What is the shortest time that the boat can cross over to the other side in? For the shortest time, the boat must head out perpendicular to the river bank. So our intended direction of travel must be perpendicular to the river bank, which means that the vector vb with respect to r must be perpendicular to the river bank. It has the same magnitude of 5, but the direction is now vertical. The river current vector will not change. It will continue pointing towards the right. The vertical distance is 100 meters, and the velocity in the vertical direction, or VB with respect to r, is 5. So this gives us a time of 20 seconds, which is the least time the boat would take to cross the river. Also, in this scenario, we are asked to compute the drift in this case, when it takes the shortest time. Now we are computing the drift, or how far from point B does the boat actually reach. The component of VB along the x-axis is VR. Since this is a right-angled triangle, so the velocity along the x-axis is 3 meters per second, and the vector VB with respect to r does not contribute along the x-axis. The time taken to cross over in this scenario we had already computed a little while ago, and that was 20 seconds. So the boat takes 20 seconds to cross over to the other side. In the absence of acceleration, the drift would be the x velocity times the time that the boat travels. So the drift turns out to be 60 meters.